So last session, where we stopped, that is, we were discussing the concept of regression lines. We are discussing the concept of regression lines, how to solve a regression equation. Okay. Then lastly, we had very important two formulas I discussed very slowly also. That is because it is there in the model question paper. That means when there is, for example, if there is terms like two regression equations are given to find mean of x and mean of y. Okay, to find mean of x and mean of y, that type. So you know that we know already, we studied that whenever two regression lines intersect, their point of intersection is x bar comma y bar. That is, when we calculate the point of intersection of two regression lines, or when we solve two equation of regression lines, we get the point of intersection. That point of intersection is only mean of x and mean of y. Okay. Then to find r, that is usually they give coefficient of correlation. So what we do, we assume any one of the equation as the regression equation of y on x or x on y, whatever. And then we write it as y equals form and find byx, coefficient of x. Then another equation x on y, we write it as x equal to form and the coefficient of y will be bxy. Now from that we find r plus or minus square root of byx into bxy. Okay. Now this value of r is given positive or negative sign depending on bxy and byx, regression coefficients. If both the regression coefficients are positive, then r will be positive. If both the regression coefficients are negative, then r will be negative. Okay, now is condition arrived in the previous problem, which I had solved in the last session, that we get the value of r more than 1. It cannot be more than, we got 1.41 for something. It cannot be more than 1 or less than 1. It should be in between minus 1 and plus 1. It should be in between minus 1 and plus 1. So when you get a condition where it is more than 1 or less than 1, then again we have to change our assumptions. Which equation we took y on x, we should take x on y and find x equal, write it as x equals, and find the x equals and find b of xy there. And which we took y on x, take it as x on y, which we took x on y, take it as y on x and write it as y equals, find the coefficient of x, and that will be byx. And again redo the process. R is equal to plus or minus square root of bxy into byx, and this time you will get it. So that is the method, and very important problem from your exam point of view it is. Now today I will discuss the concept of, you can see here, the concept of same regression lines. But here you can see very important question. It is there in model question paper, and it is also repeated many times in the different question papers of VTU. Okay, very important question. This very important. I have written here model question paper. So it is a derivation type of question. If theta is the acute angle between the two regression lines, see, if theta is the acute angle between the two regression lines, acute means less than 90 degrees. If theta is the acute angle between the two regression lines, in the case of two variables, that is bivariate data, in the case of bivariate data, that is in the case of two variables x and y, show that tan theta equals 1 minus r squared by r, 1 minus r squared by r into sigma x by sigma y. Okay, 1 minus r squared by r into sigma x by sigma y. Clear? 1 minus r squared into r, 1 minus r squared by r into sigma x into sigma y divided by sigma x squared plus sigma y squared, where r comma sigma x comma sigma y have their own values. Clear? They have their own values. It's given where r comma sigma x have the usual meanings. Means own values. Then also the next part of the question is explain the significance. It's given. Explain the significance. So explain the significance of the formula where r equals 0 and r equals plus or minus 1. That means the significance of the formula, that is this formula, when r equals 0 or r is equal to plus or minus 1. R equals 0 or r is equal to plus or minus 1. I hope it is clear. Okay. Again, I repeat, if theta is the acute angle between the two regression lines, in the case of two variables x and y, show that tan theta equals 1 minus r squared by r into sigma x into sigma y divided by sigma x squared plus sigma y squared, where r comma sigma x comma sigma y have their usual meanings. Okay. Usual meanings means r is the coefficient of correlation, sigma x is the standard deviation of x, sigma y is the standard deviation of y, etc. Explain the significance of the formula. So also one extra question is there. Explain the significance of the formula when r equals 0 and means what happens to the above formula, or what is the conclusion you can draw from in the above formula when r equals 0 or r is equal to plus or minus 1, like that. Now here, first what we do, we take equation to the lines of regression on y on x and x on y. Equation, two regression lines. This is just like a theoretical type of question, but very important question. Equation to the lines of regression of y on x and x on y. We take it. Equation to the lines of regression of y on x and x on y. So y on x, the standard form we have done many times before. You can refer the notes. All of you write the notes. If you don't know, I can't do anything. So you should know what's going on. Write the notes, be up to date, and also solve assignment 1. So once I finish the portion, I will give assignment 2 questions and assignment 3 questions. So write the notes now. Don't delay. Don't postpone tomorrow like that. So y minus y bar is equal to byx into x minus x bar. This is the regression equation of y on x. This is the standard form of regression equation of x on y. X minus x bar equals bxy into y minus y bar. Now this will be y minus y bar equals, this byx can be written as r into sigma y by sigma x. The derivation no need for you, but byx can, I have told before also, byx can be written as r into sigma y by sigma x into x minus x bar. Here x minus x bar equals r into bxy can be written as r into sigma x by sigma y into y minus y bar. So these are the two clarifications which you need. So I can say total I have given before, byx is r into sigma y by sigma x. We'll use it in some problems later. And bxy equals r into sigma x by sigma x. So this is the regression equation of y on x. Two methods of writing, same thing there. This is the regression equation of x on y. Okay. Now, to find the slope, we take the first equation, y on x, that is y minus y bar is equal to r into sigma y by sigma x into x minus x bar. So slope m1, first line m1 will be r into sigma y by sigma x. Okay, why? Because why the slope will be this part, r into sigma y by sigma x, because you can recall the coordinate geometry of straight lines. What you studied in your 12th standard, in your PUC, the coordinate geometry of straight lines in your PUC level, which says if the equation of the straight line is y minus y1 is equal to m into x minus x1. If the equation of the straight line is y minus y1 is equal to m into x minus x1, then m is the slope of that line. If the equation of the straight line is y minus y1 equals m into x minus x1, then m is the slope. Using that concept here, y minus y bar equals, this we take m, slope of the line. Now we take another, that is the equation x on y. Now we take the equation what? X on y. We take the equation x on y. Okay? We take the equation x on y and see what happens. Again, same thing. Here you can see there is that is x minus x bar is equal to bxy into y minus y bar. That bxy is r into sigma x by sigma y. So x minus x bar is equal to r into sigma x by sigma y into y minus y bar. We take it, x minus x bar equals r into sigma x by sigma y into y minus y bar. So here we can't find the slope directly, because the standard form of slope is y minus y1 is equal to slope into x minus x1. So we write this in the form of y minus y bar. We write this equation in the form of y minus y bar. How? So y minus y bar is equal to, this we cross multiply, sigma y divided by r into sigma x into x minus x bar. we write this to find the slope, we write it in the standard form of finding the slope, that is y minus y1 is equal to m into x minus x1. So here y minus y bar we keep one side, remaining other things we cross multiply, sigma y divided by r sigma x into x minus x bar. So the slope now m2, for the second line we take m2, that is sigma y by r into sigma x. Here I have given the standard form of the slopes. For the line y minus y1 is equal to m into x minus x1 from your PUC level, coordinate geometry. For the line y minus y1 is equal to m into x minus x1, m is the slope. Okay, m is the slope. M is the slope. Clear? Now, you know the formula. When two slopes are given, how to find the angle between two lines. When two slopes of the lines are given as m1 and m2, how to find the angle between those straight lines, that is tan theta. That was the, again, PU, first PU, second PU formula in coordinate geometry. Tan theta equals actually plus or minus modulus of m1 minus m2 by 1 plus m1 m2. That's okay. But here we can take either m2 minus m1 or I can take m1 minus m2, both are same. So I took here tan theta is equal to plus or minus m2 minus m1 divided by 1 plus m1 m2. Tan theta equals m2 minus m1 or m1 minus m2, whatever, divided by 1 plus m1 m2 or m2 m1. I substitute the values of m2. m2 is sigma y by r sigma x. So m2 sigma y by r sigma x, and m1, it is here m1 r sigma y by sigma x. So m2 minus m1 divided by 1 plus m1 m2. If you multiply m1 m2, r get cancelled, sigma y squared by sigma x squared. Now we have to simplify this, the process of simplifying it. So it's a very important question. How we simplify it here is we take sigma y by sigma x common. Sigma y by, you can see sigma y by sigma x a common term. So remove it outside, plus or minus 1 by r minus r divided by, I take LCM in the denominator, sigma x squared is the LCM. Sigma x squared is the LCM. You know all these very things, basic things which you studied in your 12th standard or PUC. That is sigma x squared plus sigma y squared by taking LCM divided by sigma x squared. So now tan theta will be equal to plus or minus. Here also I take LCM. R is the LCM. 1 minus r squared by r. Sigma y by sigma y by sigma x into, this will be reciprocal. When you multiply this, the denominator will be reciprocal. Denominator will be reciprocal means when we divide two fractions, numerator one fraction divided by denominator one fraction, the denominator fraction will be multiplied and it will be reciprocal. So here also it will be reciprocal, sigma x squared divided by sigma x squared divided by sigma x squared plus sigma y squared. You get like this. Now whichever cancels, you cancel. So tan theta equals plus or minus 1 minus r squared by r sigma x into sigma y divided by sigma x cancel, sigma x squared plus sigma y squared. That is the derivation. Okay. Now you know that r squared, see, r squared is in between minus 1 and plus 1. Okay, we know r is in between the coefficient of correlation. The value of r is in between minus 1 and plus 1. So when you square it, the maximum value it can attain is plus 1. The maximum value it can attain is plus 1, not anything else. The maximum value it can attain is plus 1. So r squared is always less than or equal to 1. So r squared is always less than or equal to 1. Okay. I hope it is clear. The value of r is in between minus 1 and plus 1. So r squared is always less than or equal to 1. And sigma x and sigma y are taken positive here. The standard deviation of x and standard deviation of y is always taken positive for regression lines. We take it positive here in this particular case. Okay. Positive sign, because negative means we want acute angle. So positive sign gives the acute angle between the lines. Therefore, this is also positive. Okay, this also r squared less than positive. These are all positive. So we get positive sign only here. So positive means tan theta is positive means theta is in the first quadrant. Theta is in the first quadrant means theta is acute angle. So that I have written here. Positive sign gives the acute angle between the lines. The positive sign gives the acute angle between the lines. Okay. The positive sign gives the acute angle between the lines. The positive sign gives the acute angle between the lines. That is clear to you. Studied in coordinate geometry. Now, tan theta will be equal to, we take only positive sign, 1 minus, because it is positive. I told you why. R squared is always less than 1, less than or equal to 1. So 1 minus r squared less than or equal to 1. and the rest. So tan theta equals to 1 minus r squared by r into sigma x sigma y by sigma x squared plus sigma y squared. So when r equals 0, so now we have to answer the next part of the question. We derived the result. Now the next part of the question, the significance of this result tan theta when r equals 0 and when r equals plus or minus 1. Okay. First we'll discuss when r equals 0. When r equals 0, you know, when r equals 0, what happens here? Theta is pi by 2 because here 1 minus 1, when r is 0, this will be 0. So here from 0, so when r equals 0, theta is pi by, theta is 90 degrees. Okay, because tan 90, theta is 90 degrees. Because here what happens when r is 0, it will be infinity. When r is 0, whatever the value here, whatever the value here, this is 1. 1 by 0, 1 by 0 is infinity. Tan theta is infinity. Tan theta is infinity means theta equals pi by 2. Again I repeat, when r equals 0, this will be 1. This will be some numbers, okay, standard positive numbers, but any number divided by 0 is infinity. So tan theta is infinity and theta will be equal to pi by 2. Tan theta is infinity and theta will be equal to pi by 2. Okay. The two lines of regression are perpendicular to each other. That means when r equals 0, what it shows? The theta pi by 2 means the angle between the two lines is 90 degrees. That means the two lines of regression are perpendicular to each other. That means what is the meaning? The variables are independent. The two lines are perpendicular to each other means the variables are independent. Remember, two lines are perpendicular to each other means variables are independent. That means the estimated value of y is the same for all values of x. So when theta is pi by 2, the lines are perpendicular to each other. That means the variables x and y are independent. That means in another way of telling, the estimated value of y is the same for all values of x. Estimated value of y is same for all values of x and vice versa. Or the estimated value of x is same for all values of y. Variables, or you can say the variables are independent. So this is the answer when r equals 0. The lines are perpendicular. If the lines are perpendicular, the variables are independent. That means the estimated value of y is same for all values of x, or the estimated value of y is same for all values of, estimated value of x is same for all values of y, vice versa. Okay, now we go to another case when r is equal to plus or minus 1. Okay, when r is equal to plus or minus 1 in both cases, whether it is 1 squared, it is 1. Whether it is minus 1 squared, also 1. So 1 minus 1 will be 0. So tan theta equals 0. So theta equals 0. Tan theta equals 0. So that theta is 0 or pi. Theta is 0 degree. Even tan pi is 0. So theta is 0 or pi. Here the lines of regression, theta is 0 means the lines of regression coincide. Angle between the two lines is 0 means either they are far apart or they coincide. The lines of regression coincide. When they coincide, what we say? When the lines of regression are coincide, I discussed this before, there is perfect correlation between the two variates x and y. So when r is plus or minus 1, tan theta will be 0, I explained, because if you look at this, when r is plus 1, r squared is 1, 1 minus 1, 0, 0 divided by anything or into anything is 0. When r is minus 1 squared is 1, 1 minus 1, 0 again. So tan theta is 0, theta equals 0. So what happens when tan theta is 0, theta is in between 0 and pi. Theta can take the value 0 or pi. We are bothered about what happens to theta 0. That means when theta is 0 or pi means the lines of regression coincide. Imagine. So the lines of regression coincide means it shows that there is a perfect correlation. It shows that there is a perfect correlation. It shows that there is a perfect correlation between the two variables x and y. There is a perfect correlation between the two variables x and y. So it shows that there is a perfect correlation between the two variables x and y. Okay, that is the answer for that very important model question paper problem. Please solve it. Now this problem is similar to what I did in the previous class, but it's a question paper problem, so I solved it. That is, two regression lines are given and then finding all the other values. Mean of x and y, standard deviation, coefficient of mean of x and y we have calculated yesterday. Coefficient of correlation was studied, but standard deviation is the new question, that's all. So I'll solve one question and one question I given for homework, and at the end of this we complete this module. This module is complete, that is module 4. Tomorrow session I will start at 12, that is the module 5, joint probability distribution. So in a partially destroyed laboratory record of in a partially destroyed laboratory record of an analysis of a correlation data, Again I repeat, in a partially destroyed laboratory record of an analysis of a correlation data, the following results only are eligible. The following results only are taken into consideration. So what it is given? Variance of x is 9. Regression equations are 8x minus 10y plus 66 equals 0, 40x minus 18y plus equals 214, 214. What were the mean values of x and y? So x bar and y bar. The standard deviation of y. This is a new question, but it's very simple, we can calculate. And the last one, the coefficient of correlation between x and y. Coefficient of correlation between x and y means we have to find the value of r. Now, since x bar y bar is the point of intersection of the regression lines, we solve these two equations. That is, we write it as 8x minus 10y is minus 66 and 4x minus 18y equals 214. 40x minus 18y 214, and solve it either by your usual method, adding, subtracting, or best method is use calculator. So you'll get same answer. All should get same. All of you should get same answer. X equals 13, y equals 17. Now this is got by solving the two equation. That means it is the point of intersection of the two regression lines, and you should know the point of intersection of two regression lines is always the mean. X coordinate is the mean of x, y coordinate is the mean of y. So x bar equals 13, y bar is 17. So mean of x is 13, mean of y is 17. Now to answer the second question, it is given here variance of x is 9. So variance of x is 9 means sigma x squared, because standard deviation is equal to square root of variance. So variance is equal to square of standard deviation. So variance of x is 9. So sigma x squared is 9. So sigma x is 3. Plus or minus 3, we take only positive here. we consider only positive. Negative case, no need. In standard deviation. Let us assume, now again there are two lines as before the problems we solved last session. Let us assume the regression equation, this one as y on x or whatever it is, y on x as 8x minus 10y plus 66 equals 0. And when it is assumed as the regression equation of y on x, write it as y equals, keep only y one side and divide 8 by 10 will be 0.8, 66 by 10 is 6.6. Another equation given we'll take as regression equation of x on y, that is 40x minus 18y is 214. So find out x equal, write it as x equals, take this to the other side, divide by 40, you'll get x equals 0.45y plus 5.35. Now this will be coefficient of x. In regression y on x, y equals 0.8x. This 0.8 will be byx. So the regression coefficient of y on x, regression coefficient of y on x, that is byx, is 0.8. So that is nothing but I also gave the formula, because here you have to find standard deviation. R into sigma y by sigma x is 0.8. I give it name 1. Similarly, the regression coefficient of x on y, b of xy, bxy equals 0.45. For that formula is R into sigma x into sigma y. R into sigma x into sigma y equals 0.45, because this value, coefficient of x when y on x, will be the regression coefficient of y on x, that is byx. When we take a regression equation x on y, write as x equals, and the coefficient of y will be bxy, that is 0.45. Okay, byx is also written as R into sigma y by sigma x. Another formula for byx which was studied from before, you can refer the notes. R into sigma y by sigma x is 0.8. Take it as equation 1. Then regression coefficient of x on y, we got bxy is 0.45. Coefficient of y is R into sigma x into sigma y is 0.45. This is byx, this is bxy. So R is plus or minus square root of byx into bxy, that is plus or minus square root of 0.8 into 0.4y, that is plus or minus 0.6. But since both byx and bxy are positive, here 0.8, here 0.45, R also will be positive. Since both bxy and byx are positive, the regression coefficients of both lines are positive. So coefficient of correlation R is equal to 0.6 will also be positive. Now we answered two questions. Now we have to find standard deviation. So for that I use this first equation, because I want to find standard deviation of y. Or I can use this, any one equation. I use this. So R into sigma y by sigma x is 0.8, or you can use the other equation. So 0.6 R you got. Sigma y we have to find out standard deviation of y. Divided by sigma x is 3. Somewhere we got here. See, sigma x is 3. Okay. So put the sigma x value. So we get here, when you write the sigma x value as 3. So from this we find sigma y. So sigma y is 0.8 into 3 divided by 0.6, that is equal to 4. So we calculated the first sub question A to find the mean of x and mean of y. We got x bar equals 13, mean of x, the x coordinate when finding the point of intersection we got as 13, and the y coordinate of the point of intersection of the two regression lines we got as 17. So now x bar is 13, y bar is 17. That is the first answer. Okay. Now we find B. We take this here. Sigma y, that is we got here 4, the second answer, standard deviation of y is 4, and then the coefficient of correlation R is 0.6. It is positive because both the regression coefficients are positive. This is a very important question. Now same type of, it's not same type, it is same question I have given here one, that is for homework for you, and I will not solve it. Answer is also same. See, x bar is equal to 13, y bar is 17, R is 0.6. Why? Because see the first question, 4x minus 5y. See, in a partially destroyed laboratory record, the lines of regression of y on x and x on y are available as 4x minus 5y plus 33 equals 0, 20x minus 9y equals 107 respectively. So these two lines are same as this. See, 4x. So divide by 2. 4x minus 5y plus 33 equals 0. See, the same problem. 4x minus 5y plus 33 equals 0. And see the second line. See the second line here. 40x minus 18y, that is, you can divide here by the common term, 2 first or whatever. So we get here by dividing by the common term, it is the same line. We get 20x minus 9y equals 107 respectively. So same problem, but you asked in another way. Please solve it separately and you see you get the same answer. So once again, I would like to summarize what we did today. So this problem here, first, to find x bar and y bar, I just give the hint for you. To find x bar and y bar, find the point of intersection of the two regression lines. The point of intersection of the two regression lines will be mean of x and mean of y. The point what you get, x coordinate will be mean of x, y coordinate will be mean of y. You can solve it by using calculator. Then to find r, we assume that this equation is y on x, this equation is x on y. Write this as y equals to, write this as x equals to. In the equation what you wrote y equal to, you get byx, coefficient of x, what is there, you get byx. In the equation what you wrote x equal to, the coefficient of y, you will get as bxy. So once you get byx and byx, r equals plus or minus square root of byx into bxy. Many problems you have solved and you get the value, I think plus or minus 0.6. But since both bxy and byx are positive, r will also be positive. So r will also be positive. So since r is positive, we get r is 0.6. So this is the method to calculate this. So now we have solved enough number of problems in regression equations. So in this particular topics, we studied coefficient of correlation, different methods, then regression lines. Then also you studied the different formulas, different types of problems, very important problems I've solved. Now your work is to, this module is completed here. That is module 4 is complete. So your work is to solve the problems in module 4. 90% I've solved, 1 or 2 problems. Try to solve it. If you don't get, I will solve it later. Okay. And tomorrow in the next session, that is tomorrow at 12, I will start module 5. That is joint probability distribution and sampling theory. So it's a little bigger. First part is connected to this, little smaller, but the next part, that is sampling theory, is little big. Many tests are there, many problems are there. So now what is done here, module 4, copy the notes, be thorough in that and solve all the problems. Be thorough in the model question papers, solve assignment 1. At the end of module 5, when I finish module 5, I'll give you the questions of assignment 2 and assignment 3, hoping that by that time the lockdown might be complete. Okay. So prepare for the exam, write the notes. Once again, I'm telling you, write the notes, write and study all the concepts. Clear? Now you can see this problem. That is the first problem which I did today. It is very important. Tan theta, very important. The two significances, very, very important. Please solve that problem and keep again and again. Write it. Then even the second problem what I solved, we have solved the same type of problem in the last session also. But the way of asking was different, that's all. So this problem is also very, very important. So I hope you will write the notes, and also solve each problem, and each problem it is based on calculators, so be thorough in calculators. Once again I am requesting you, be thorough in calculators, and my answer might be correct, just to be approximately 4 decimal place always. So write the notes. Again I am repeating, assignment 1 you solve it, and tomorrow I will start module 5. Okay, all the best, thanks.